Let's begin the last talk of this session, this workshop, MongoDB specification in Maude by Beatriz Alcaide.
Okay, so this is probably going to be a very short presentation because I'm not going to lie, I'm very nervous. This is my very first talk. So it's actually my bachelor's thesis last year. And okay, let's start. Okay, first of all, what is MongoDB and what is Maude? MongoDB is a distributed NoSQL database management system. It's document-based and JSON-like documents. And Maude is a language that serves both for specification and programming purposes because of its executable semantics. It's based on rewriting logic and membership equation logic. Rewriting logic is the logic of change. And as I mentioned earlier, MongoDB is document-based, so it has collections containing multiple documents where the data is stored, and a single MongoDB instance is capable of hosting multiple databases, each with multiple collections. I specifically focused on MongoDB's distributed architecture. MongoDB, when MongoDB receives a request, it sends set request to the Mongos, which acts as a router. The Mongo has a cache memory that is used for the versioning protocol, which I will explain later. It uses the config server to send the request to each particular shard. Each particular shard is an instance of a replica set where the data is replicated. In MongoDB, we can have both sharded and unsharded collections. And unsharded collection is, well, MongoDB distributes its data on a document level. That is, it can partition collections, but it cannot partition a single document. So it can have sharded collections where, like for instance, the first collection, and it can also have unsharded collections. To know where each document is on a sharded collection, it uses something that's called a shard key. A shard key can be both be hash-based and range-based. Now to the specification. This is a very abstract design concept of the specification, but for most of it, it was Maude based. The cache memory, what it does is the cache memory stores the namespaces, which is the combination of the database name and the collection name. And it stores also the information of, and it maps it to the written information, where each document is stored in each cluster. It uses the cache memory for the versioning protocol. This is a way to make sure that there is no bottleneck for when handling multiple collections with multiple requests, right? Because all the information is stored in the config server. So this way, what it does is it it handles requests optimistically. It assumes that the information is already the written information is already on the cache memory. If the cache memory and it has a version assigned to each to the shards, and if the version is stale, it checks the version of the cache memory on the shard. If the versions don't match, then it sends a stale configuration error. It updates the cache memory, and then it sends the request to the appropriate shard. Now, to replicate to mimic the non-deterministic behavior of, okay, well, first of all, what is a replica set, right? A replica set is a set of nodes where the information is replicated. To make sure that it uses what is known as an oplog, operation log, where to ensure a causal consistency. So each operation is applied to primary node, and then that operation is the rest of the nodes read each operation from the oplog. So to mimic that behavior, the primary node receives an update replica set message. It then updates the primary node and the oplog, and when both are updated, it sends an update secondary message, where it updates each. Well, it's secondary until all nodes are updated. This is not only a specification, but also a prototype. So we really also wanted to make sure that it was functional, right? So we also included we also include queries. They both insertion and find queries and range-based find queries. And this is basically what it does. This is a very quick overview of the behavior of the query, but first, well, it basically checks one by one each document on a collection. And if it meets the conditions of the query, and well, future work, conformance testing to make sure that this really aligns with MongoDB's actual behavior. It would also be appropriate to model the consensus algorithm that is used on the replica sets. MongoDB uses a Raft-based consensus algorithm, which the Raft consensus algorithm is already, there's already previous work that has already model checked that algorithm, but the specific algorithm that MongoDB uses is not already formalized. It would also be appropriate to further expand the query operators on the indexes and to model check the specification. And that was pretty much it. Thank you.
Thank you. Questions, comments?
Do you have use cases? Of applications, did you try to model concrete applications to test the expressiveness of your?
Yeah, but I'm gonna be honest, I don't really understand the question.
So you have a model, but did you try to make concrete applications using the encoding?
Yeah, it's actually, yeah, as I mentioned, it's also a prototype, and you can actually like use it to store information to.
What kind of applications did you model?
Yeah, it's just MongoDB, the database management system.
Antonio tries to ask if you have some application that uses MongoDB, right? So, but I think for the time being, it's only checking queries. So introducing data and consulting data.
Yeah.
Not real applications using the database, but just the raw database, just queries.
It is just read operations.
Read, insert operations, both unsharded, unsharded.
So did you try all CRUD operations of databases, create, write, read, update, delete? Okay.
More questions, comments? Let's thank Beatriz again.